Here we're going to take a look at the bubble sort and how it works. So I have an array here of data that's unsorted, and we're going to step through the process of sorting the data. So the bubble sort swaps two locations at a time, going through the entire array. And the concept is, based on its names, that the highest value, if we're sorting in ascending, will bubble its way up to the last location. In this case, index 6, which would be its final place that it will reside in the array once it's sorted. So it starts with looking at index 0 and then n1 and comparing those two. So in this case, those two are out of order. So basically it sorts two elements and then moves to the next two. Alright, so it's going to sort those two and swap those two values, putting the 10 and the 23 in those corresponding locations. So I'm just building other arrays to show you the pass for each time. So we're building on the first pass right now. So now it's going to shift by one index and compare index 1 and 2 together. Seeing those two are out of order, so it will swap those two values. Then moves down by one again to the indexes 2 and 3, compares those two, where we have the 23 and the 15. Those are out of order, so it swaps those two. And it continues for the rest of this pass doing that, and you'll see that the 23 is bubbling its way up. So it's comparing indexes 3 and 4, swapping those two. Then it's comparing indexes 4 and 5. In this case, needs to swap those two, and does that. Gets to the indexes 5 and 6. Those also need to be swapped, so it proceeds to swap those two. So that's the end of one pass. Data's still not fully sorted, but the highest value in the array did make its way to its final index of 6. Now, just happened to work that 18 is also at its final place, but nothing has done that to put it there to ensure that it's there. So it does do a pass to move supposedly to 18, but in the process it continues to swap locations. So it starts all over at index 0 and compares index 0 to 1, in this case the 10 and the 4, so it needs to swap those two values. The 10 and the 15 are in proper order, so it will not swap those two. It will then look at indexes 2 and 3 and see those two are out of order, and it will swap those two. It will then look at index 3 and 4, see those two are out of order, and it will swap them. Then it looks at index 4 and 5. They're in proper order, so it will not swap them. And it does not look at index 6 because it already knows that one's in its final spot. So at this point, after two passes, we know whatever's at index 5 and 6 are in their final spots. Again, 15 just happens to be in its final spot also. But it will need to check that location on the next pass. So on the next pass, the 4 and 10 are in proper order, so it does not swap those. But the 10 and 7 are out of order, so it swaps those two. The 10 and 1 are out of order, so it swaps those two. It will check indexes 3 and 4, see that they're in proper order, so it will not swap them. And again, the rest we know are in their resting places. So 15, 18, and 23 have bubbled up to their final locations on that pass. And the next pass just continues that. We know that the next value looking at it's 10. Again, another one that made it to its final spot by just the algorithm doing what it does. But it will look at 4 and 7, nothing to swap there. The 7 and the 1, swap those two. It will compare indexes 2 and 3, and nothing to do, so it will not swap. And the rest stay where they are. One more pass, and that puts us in our final sorted locations. Right. 1 and 4 needs to swap. It compares indexes 1 and 2 and sees those two are in order, nothing to do. It will ignore 3, 4, 5, and 6 because those we already know are in their spots. Now, to guarantee that it's fully done, it will need to do it one more time, and it will do no swaps in this case. So the 1, the 4, the 7, the 10, the 15, 18 and the 23 after one more pass will all be in their final spots. And that's the bubble sort.